Hello, today I want to introduce you to a couple of forging techniques, tapering and flattening. For this study we're going to be employing copper wire. This is round number 6 copper. It's about half hard as it comes off of the coil, so we're going to need to fully anneal this before we can work with it. Let's begin by putting a good heavy coat of flux on it. I actually have boric acid dissolved in alcohol here. It's a fairly thick mixture, and that allows me to actually put a nice thick heavy coating on pieces. And that looks pretty good. Let's start with that. Put our flux away here, and I like to light off the excess alcohol at this point. That helps flash that away. For this annealing operation, we're going to be using the the Miko in midget torch. I run mine on oxygen and propane. It'll also run on natural gas, and I'm not using a tip. That allows me the largest, bushiest flame, which is appropriate for such a large piece. Let's go ahead and fire that up, get it adjusted. We'll adjust that down till we get a fairly good reducing flame going here. I've got a little bit of unburned fuel showing out the tip here. That's too much, so let's bring it back a little bit. And that's probably appropriate. I have some sprung parallel jaw pliers here to actually grab the piece and dunk it in the water to quench it. The copper tongs I usually use are a little too light for that heavy a piece. Let's darken the area a little bit so we can actually see the color temperature of our metal. And I'm going to direct the heat down onto the brick just under the piece there. It helps reflect it back up, and it also absorbs a little bit of heat, so it can be a bit of a heat sink. We'll go ahead and heat that up first. And our annealing temperature is a dull red glow for most metals, for at least non-ferrous metals. So to get to annealing temperature, we're just looking for a dull red glow. We don't want to get up close to a cherry red or anything like that. That's a little too hot, and the metals can become a little bit brittle at that point. So there's a ideal temperature for annealing, and that's the temperature we're looking for. And the best way to judge that is by the color temperature. And I'm directing the flame kind of along the piece to kind of get the most out of my gases, and direct that heat into the piece. And such a large piece as this, it can take a little bit to actually get up to temperature. Copper is very conductive though, so any heat you put in on one end almost immediately runs to the other end. And we will try to get the entire piece up to a dull red glow, and that will become an appropriate quenching temperature. And I see now that we are there. So let's go ahead and drop that in the water. We'll lock that annealing in place. And my water isn't quite deep enough, so let's flip it over. And there we go. Now we're quenched. I will drop that in the pickle and get that out, clean it up, and I will meet you at the forge. Okay, we are at the forge. I want to start by speaking a little bit about how to determine the suitability of your striking surface. This is a 22-pound anvil. It's made by Weaver. It's cast steel. And one of the tests you can do is actually just give it a strike test, and you're listening for a good return ring. And that sounds pretty good. And you want to strike it in several different places to determine where you're getting the best rebound. Here it goes a little bit dead right there, and picks back up on the end here. Same thing, it's dead here. So I've got a couple of dead spots here that are not necessarily going to be great places to forge on. Another test you can do is actually drop a ball bearing onto the forge, and you should get about a 90% return. If it doesn't return quite so much, that means you've probably got a void inside the casting, or it's delaminated down in the interior. And the reason that's important is because when you trap the material between the anvil and your hammer, some of that striking force is actually being transmitted through the piece and into the anvil, and the anvil is absorbing that. If your anvil has a good return, then all that energy actually gets put into the piece that you're actually forging. This is the number 6 annealed wire, and I've affixed it into a jeweler's hand vise. And I brought out a couple of studies that I did at the Revere Academy. This began as a number 4 round wire, and the assignment was to do a reverse forging on that, so that we ended up with 4 flat planes that were equally spaced, and to make this transition, and it would be right across the middle. We'll be doing today. We'll learn how to actually forge this flat area. I'll show you a couple forging techniques for that. This piece was actually a number 6. Yeah, I think a number 6, a little smaller actually, probably a number 8 copper wire. And the assignment was to forge out a taper and then curl it up into a decorative curl. We're not going to be doing the decorative curl today. We're going to be doing the taper on the wire. Show you how to actually use a forging technique for tapering that end out. So let's begin. The first one, we're going to actually work on putting a taper on the end of this wire. We're going to take our cross peen end here, and that's this edge here, and it's got a little bit of a curve in both directions. A little this way and a slight curve this way. And as I strike this, what's going to happen is most of the force is actually going to cause the metal to spread out away from this cross peen. Not so much across it, but along it. So let's begin out here. We'll start on the end, and we'll just put some light taps in the end here. And we'll probably go up in about 1.25 inches, 1.5 inches, something like that. And we'll lighten up as we get a little towards the top. Okay. And let's flip that over. As I was striking it on that side, I actually ended up with a flat spot on this side a little bit. So that tells me when I've got that face down. So let's repeat that action. And I'm not striking very hard. I've got the handle held down here close to the heft, so that I'm letting the hammer actually do the work. Okay, then let's turn that 90 degrees. Repeat that action. And we'll do more peening down here on the end where we want the taper to begin being introduced. Okay, then let's flip that 180 degrees there. Repeat that action. And we want to see a nice, even spacing of our peens. Okay, and then we'll orient that 45 degrees to that last one there. Begin on the end. More peens down here on the bottom end. That's where we want the most taper. Let's turn that 180 degrees. Orient that again. That's face up. Okay. And doing this can actually save you the trouble of trying to abrade that material away to make your taper. And because a lot of times you're just turning that material into dust, and I mean that could go into your bench sweeps and be recovered that way. But using this method, you're actually making the best use of your material. This doesn't actually remove any of the material. It just rearranges it a little bit. Okay, and I've got one corner left here that we haven't forged yet. So let's do this side a little bit, and I think that will complete our first elongating forge. And I'm starting introduced into this. It's getting a little thinner towards the end. Now we're going to switch up. We're going to go with the planishing face here. And we're actually going to start at the top and kind of blend those lines together. Striking on the faces pretty much oriented straight up and down to where I was actually introducing the peens. We'll go back and blend the high points between those as we continue around here. And I can feel the metal beginning to harden a little bit. You can hear the return coming back from the anvils getting a little louder. Okay, now we've pretty much blended all of those those areas, so we've got high spots in between those faces. Let's turn it up so that's oriented up, and we'll take that down. We'll just continue around like that. Like this. The reason for doing this peening in between the elongating is just to kind of even all the metal back out. Okay, and we're starting to see just a little bit of taper introduced into the end here. This metal hasn't quite hardened yet, so we can do one more set of elongation and peening. So let's begin that process. Copper's a little more amenable to this than sterling silver is. Sterling will tend to harden a little quicker. So you can get a little more out of this process using copper than you can with sterling between your annealings. One thing to keep in mind while you're doing this is you want your hammer to actually be striking exactly across. If you start to lean a little bit, what you'll do is you'll introduce more curve on one side than the other, and it'll start to take a curve. So you want to be careful to avoid that while you're doing your forging. That's just, the vise is loosened up a bit here. That's just a matter of orienting your hammer and your offhand here that's holding the material, and making sure that your hammer is actually striking perpendicular to the axis. And many small strikes work better than just a few heavy strikes. Gives the metal a chance to actually adjust and change shape over time, as opposed to trying to do it all at once. Now we're going to go between those four sides. And the metal is starting to harden substantially at this point. I can feel that my hammer is actually returning back a little bit off of the material. So really, as you're doing this, you want to pay attention to the sound that you're getting back, the way that your hammer is acting as it bounces against the material. And of course, you never want to just keep driving on until you're past the point of hardness. You can actually introduce cracks. So if you're paying attention to the sound and the way your hammer is acting and the way the material is acting, you'll know when you need to stop. And doing annealing. And I guess I should mention this hammer is a 300 gram, so probably 2/3 of a pound. I believe a gram or a pound is 480 grams. So obviously, with a smaller wire, you're going to see the effects of the elongation much more quickly than you do with a larger wire. So if you were to, you had an element that you wanted to introduce a tapered end onto, it happens much more quickly. And a lot of times you can do that in one series between the annealings. Going around until I've actually peened the entire surface of this. There's more peening towards the bottom, obviously. That's where we're trying to get the most taper into. And one more. I think I've got one more face here that needs a little bit of peening. Oh, there's one there. Let's go with that. And that's another reason for planishing the surface, is it kind of tells you, you can see that smoothed up surface and you can see where you haven't peened yet. Okay, let's check that. Yeah, that's completely peened all the way around, so let's return to our planishing face here. Begin to flatten that back out. And you can hear the anvil's really ringing now, so you can tell that this metal is really hardening up. So we're not going to see a lot of change in shape from this point on. But there is enough suppleness left in it that you can actually flatten this surface out. Okay, I'm going to show you here. We've actually got a little bit of taper introduced here. It's not quite as thick here on the end as it is here where we originally started. So to continue that taper, at this point I would go ahead and anneal this and then just repeat this process until you get it down to where you want it to be. Now after you do the final planishing on it, you're only going to have a little bit of cleanup left to do. You see you've got some dents in there, just a few. And cleaning that up with a file, sandpaper, and that sort of thing is quite simple once you've peened that surface down and got most of those high spots out of there. That just leaves a few to actually blend together. So that's how you actually introduce a taper into a shape. Let's switch this over to the other side now. I'm going to grasp the piece by the end we just tapered, and that will free up the other end. And in this case, we're actually going to employ the cross peen in a little different manner. We're actually going to peen across the piece. We're going to try and widen it out, and what I want to do is just kind of wind up with a flared end, and it kind of tapers down as well. So we'll turn it crossways, and we'll actually introduce the peening right here on the top of it. And if you need to, you can turn it a little bit for these initial passes. It doesn't really like to strike that round surface quite so much, and then do a little bit and then cross it up the other way. Okay, now I've got kind of a flat area going on there, so now I can actually go across and start to introduce some spreading there on this face. Do more on the end. Obviously we're trying to flare it the most at the end, but you want it to be a nice even flare. In this case I'm trying to get an even flare, nothing with a really strong curve. If we wanted to introduce a strong curve into this area and have it really bend out sharply, we could concentrate most of our flaring just on this end and just a little bit here, and that would actually cause the metal to bend more sharply here at this area. Okay, let's turn that over. Orient that 180 degrees. As I was hammering on the other side, I got a nice flat spot going on this side, so I can see where that's actually at. And again, we'll start with a little bit of a cross peen here to introduce that, widen that flat area out just a little bit so we can get in there with our cross peen. Okay, I've got a nice flat area going there. That's wide enough I can actually get in there with my cross peen. Now if you're working with a really small wire, you can actually do this. Obviously the cross peen is going to be a little too large to get in there and actually hit the top of the wire. It's difficult enough just to hit this large wire with this cross peen. You can actually use a ball peen, and it will spread the metal in all directions. And you'll end up with something very similar. It achieves the same end. Alternatively, you can use the cross peen like I'm using and just striking it at about a 25-30 degree angle here, and it will go ahead and spread out a little bit. And you can see that actually leaves a very nice taper, or a nice texture on that surface as well. That can be used to introduce some kind of decorative feature into it as well. So another alternative for achieving texture. Okay, now we'll turn that over, and you can see that as I was hammering on the other side, it actually flattened this side against the anvil. So we've got actually a nice planted surface here. No need to use our peening surface, or our peening face there to actually flatten that out. We can go right to this process. concentrating most of my blows right here on this last half. And we're starting to get a little bit of a spread now. A little bit about the offhand. You actually want to raise or lower or twist your metal so that it's always, wherever you're striking, it's always in contact with the face of the anvil or your striking surface. So if you need to raise it up or give it a little turn, don't be afraid to do that. Okay, you can kind of see the striking pattern there. Let me orient this so you can actually see it. There we go. So you can see we've introduced a little bit of a taper into the end of that as well. Let's go ahead and peen that area flat now. Turn that over and do the same on the other side. And then we can turn it up on edge here. Work the edge a little bit just to kind of flatten it out and even it up. And we'll switch it over and do the other side. Give it a couple of strikes right there to even it all back out. And you can see a little bit on the end here. It's got a little twist in there as well. Okay, now let's take a look at what we've accomplished in that series of forging. We actually went from a round shape to a flat, and we've tapered it this way so that it actually starts out thick and then gets thinner towards the end. And we've gotten wider here towards the end. So that is the basics of just a couple of forging techniques. One for creating a wider flat area, and the other for creating a taper on the end of a piece of wire. You can create a taper on square wire just as well. That tapering works just as well. And you can mix those two techniques together to create various shapes. So I just wanted to share that with you today. I hope you enjoyed working with me. Be sure to like, comment, and subscribe. Thank you.